everyone, in this video we're going to look at rates of change and average value. And the reason we're doing these together is not because they're similar. All right, they're not similar in the sense that your working out is the same. It's just because students get them mixed up because we have average value and average rate of change. So if you look through past assessors reports, you will see that they state students get the two mixed up. So going through this worksheet showing you rates of change, which we've already covered, and average value, hopefully you will see the difference between the two. All right, so we looked at rates of change when we did differentiation. So your average rate of change, let me just get my whole water. All right, so your average rate of change is just the gradient between 2 points. So basically rise over run. So there's your rise over your run. So you should know this formula. We've done this before. So it is just y2 minus y1 over x2 minus x1. But you can see here a and b are just your x values, and then they're substituted into your function, which is y. All right, so it's just your rise over run. Instantaneous rate of change, we're not going to focus on that in this video because we want to look at the average value function. But instantaneous rate of change is finding the gradient at a single point. So average rate of change is, let's just say we've got some sort of curve happening. We want to know the average rate of change between 2 points. So we find the gradient of a line, whereas instantaneous rate of change is finding the gradient at a point, all right, a single point, and that's when you would find the derivative at that point, the gradient at that point, and you can see it is written there. All right, so I mean you can do these questions. Maybe we'll just do the first one so I can show you what the average rate of change is, just a little bit of a review. I might get rid of this graph though. Okay, so we've got function is a over x minus 4. And we've got a domain, it just is saying any real number excluding 4. So the average rate of change of f from x equals 6 to x equals 8. So all I need to do is f of 8 minus f of 6 over 8 minus 6. Okay, and it doesn't actually matter what order you put it in if I did 6 and 8, but just make sure you're consistent. So you can see that in your formula, your B's come first, or you could do your A's come first. Whatever one you do, you just got to be consistent, but you'll still get the same gradient. Okay, so this is in terms of A. So you can probably define this on your calculator. It's probably not actually that hard to do by hand, but let's do it on the calculator because I want to. All right, so I just had to open up my calculator. Okay, so we are doing, oh, this is so annoying when the computer doesn't cooperate. All right, you can define the function. I probably wouldn't bother. So we've got a over, and you can use a. Let me just go up a little bit. All right, a over x minus 4. So for the first one, it's going to be 8 minus 4. And then, whoops. Just make sure you got your cursor in the right spot, minus the same thing. So I'm just going to highlight that. And can I shift that over? Yeah. All right. And then we're going to put the 6 there. And then 8 minus 6 on our bottom. It actually wants to type. Thank you. All right, so we've got negative a on 8, and there it is, answer E. So quite simple to do average rate of change. You've just got to remember that it's asking for the average rate of change. Okay, average rate of change is not the same as the average value of a function. All right, so have a go at those other questions. I have also given you solutions. All right, so looking at the average value. So the average value formula is quite easy to remember, and unfortunately it is not on your formula sheet. So when you're thinking about calculating the average of something, so if I was to do the average height of people in our class, I would obviously measure your heights add them all up, and then divide by 16 because there's 16 of you in the class. Now, that's also the same as the mean, all right? So that's how we calculate the mean. Your average value of a function is kind of the similar concept. So we're looking at the whole area, all right? So think about we're adding the whole thing up. We're taking the whole area, and then we're dividing by how many we have. It's a little bit more complex than that, but basically what we've got here with our absolute value function formula is the same as saying, all right, here's my definite integral from a to b, and I'm dividing it by b minus a. I probably shouldn't have written over that writing. Okay, so it's the same thing. So multiplying something by half, so if I had a half times x, is the same as x over 2. Okay, so it's the same thing, it's just written slightly differently. Now, how the textbook explains the average value, I feel like it complicates things, but it is the height of a rectangle having the same area as the area under the graph of the interval. Now, you don't need to remember that. All right, you just need to remember the formula, and if the average value is on exam 2, then your average value function formula should be in your bound book. And remember, it is not the same as average rate of change. All right, just because they both have the word average does not mean they're the same. Completely different things. All right, so let's just say, for example, so I'm going to use this example here. So we've got our function f of x. All right, so there it is. And we're looking for the average value between a and b. Now, you would find the area, the whole area under that curve. I might just do it in a different color. So that yellow part is just your rectangle. So that's, oops, come on, why aren't you highlighting? Okay, my stylus ran out of battery, so I've just charged it. Yeah, so there's the area under the curve. Hopefully we can finish this video before my stylus dies again. All right, so there's your definite integral, the area under the curve. So just ignore that, the yellow rectangle. Now, if we wanted to find the average value of that function, then we just, sorry, what are we doing? There we go. We just look for the distance between A and B. So here we don't know what A and B are, but let's say A was 2 and B was, I don't know, 10. All right, so the distance between them, you would just say is 10 minus 2, which is 8. So your definite integral from A to, well, not in this case, A is 2 to 10 of f of x dx divided by 8. Now dividing by 8, remember, is the same as multiplying by 1/8. And that's your absolute value function formula. All right, so let's have a look at a few questions before my stylus dies. All right, I'm going to ignore that first one because it's done slightly differently. Let's have a look. Oh, that one's a bit tricky. Let's see what we've got here. Oh, then that's multiple. This question is good. We're not going to do this one together, but you'll have the solutions because it does actually show you, here's a question, and then we've got the minimum value of f, the average value of f. Oh, sorry. No, don't worry. Maybe we'll do that one. Sorry, I read this right here. I thought it was the same question. The average rate of change. All right, and this is a past VCAR exam question. Average rate of change and the average value. So probably the people who are writing the exams are thinking, oh my God, students keep getting them mixed up. Let's just do one question where you're doing both of them. All right, so average rate of change, average value, different questions. All right, let's have a look at this one here. So I'm not going to do every question. As I said, my stylus is dying. Okay, part of the graph of f, which is e to the power of 2x minus x, is shown below. Find the minimum value of f. So we've got to find this value here. Now I have no idea. I'm assuming it is an exam 2, because if we're looking for that minimum, this is really frustrating. Let me just pause and I'll have a look at my solutions to see if I did on the calculator or by hand. I did do it by hand, and just to save me time and to save my poor little stylus, let's just have a look at my solutions here. So remember, if you're looking at the minimum or the maximum value, basically we're looking at stationary points. So we've got to find the derivative, okay, which is here, and we let it equal 0. Okay, so to find a minimum or to find a maximum, we find the derivative and let it equal 0, and then we're basically just solving for x. So it's quite a complex one to solve for x, but you can see all the working out there. And I'm just having a look what my final answer is. So we're solving for x, which is here, but your minimum value is not x, it's your y. So basically we found this x value, which is your -1/2 log base e of 2, but we want the corresponding value here for your minimum. So we've got to substitute that x value back into our equation, which is here. Now, if you were doing it on your calculator, much easier. So you can just go to calculation, function, we want a minimum. You can put your expression in. So frustrating when I go from PDF. Okay, so we've got e to the, I'm going to work here. Love it how he does it twice. E to the power of 2x, close your bracket, minus x. And our variable is x, and we don't really have any restrictions. Because there's only one minimum, we don't really need to restrict the domain. And come on. All right, so you can see that's your minimum value. The minimum value is your value of y, or your value of f of x. And there's your x. So we got them by hand, and then you can see it's done on the calculator much quicker. All right, let's scroll on. So the average value between x equals 0 and x equals 1. So I might actually do this question with you back here. All right, so our average value formula. So, oops, what am I doing? B minus a to b, f of x, dx. All right, so as long as you can identify a and b, and what your functions have been given to you, so we're doing it from 0 to 1. So a is going to be 0 and b is going to be 1. So 1 over 1 minus 0, which is just 1. And then we're going from 0 to 1. F of x, I did write it before, I've forgotten already, e to the power of 2x minus x. And don't forget your dx on the end. Now there's not much space here, but let's just quickly do it. So 1 over 1, we don't have to do anything with that, because so what I mean is this is all equal to 1. All right, 1 over 1 is 1. So our antiderivative, e to the power of 2x, is just e to the power of 2x, and negative x becomes negative x squared over 2. Now, when you're doing questions like this, just be familiar with your formula sheet, because this is one I always get mixed up on. So let's just have a quick look at our formula sheet, which I think is on here. There we go. All right, so e to the, I've already stuffed it up. E to the power of ax is 1 over a, e to the power of ax, and I've got to do that over 2. Silly me. All right, I don't know why I always mix that one up. All right, so substituting 1 in first, so we're going to have e to the power of 2 over 2 minus 1 squared is 1, so minus 1/2. And then we're going to substitute in the 0. So e to the power of 0 is 1, so we're going to have 1/2 and then 0. So 0 squared is 0. I'm just going to put it there for funsies. Okay, so we've got e to the power of 2 minus 1/2 minus another 1/2, so minus 1. You could put that all on the same denominator, but leaving it like that is perfectly fine. So that's just your average value. It is a simple formula. It's just substituting things in. If you're fine with definite integrals, then you're fine with the average value of a function. All right, I'm not going to do average rate of change because I would want to do Actually, I'm going to go back to this one and then we'll stop here. So the other questions you can do on your own, and I'll have the solutions there as well for you. The average value of a function from 0 to 2 pi. So that's our domain of f of x equals sine 2x over the interval 0, a is 0.4. So let's just set up that definite integral. All right, so 1 over, so b is a, and oh gosh, don't you hate that when they use the same letters? Anyway, so from 0 to a, so in this case, a is our b. All right, and then from 0 to a. All right, so 0 being our lower limit, a being our upper limit. And then we've got sine squared x dx is equal to 0.4. The value of a to 3 decimal places is. Now you can just do this on your calculator. They've got a restricted domain that has nothing to do with the absolute value function. All right, so let's go back. All right, so solve. All right, we're solving something. Yeah, I knew you were going to do that. Oh. Yep, see ya. All right, so 1 over a. Now, I would encourage you to use a. I just would hate you to get mixed up and stuff. All right, do put a times in though. Come on. All right, then let's set up our definite integral. All right, so we're going from 0 to a. Doesn't want to cooperate. 0 to a. Let's put our a back in. Now, the reason I want you to put an a in as opposed to x is, actually, it doesn't really make any difference for this one. Can't put x in though, but you could put in y or z, is if it was a short answer question and you accidentally wrote x equals instead of a equals, it would be wrong. So just be aware of that. All right, so sine squared x on your calculator, guys. So if you can remember, I'm pretty sure we would have done this in class. So sine squared x is, I might just write it here. So sine squared x is just sine x all squared. So on your calculator, just do sine squared, and I'm going to put brackets because I'm just a huge fan of brackets. They're like hugs. All right, sine squared. And then with respect to x, so just moving your cursor over, and that is equal to, what was it, 0.4. And then we're solving for a. So comma, and then we're just going to put in a. Now do use ABC. Don't use a variable. All right, use ABC. Now I'm all over the place. There we go. All right, close your bracket. Now, I don't know whether we're going to have to take note of that domain. Let's just see what it, oh. Okay, it might give us the, okay, good. All right, so it's just given us a couple of solutions. So we've got to think of our domain. So it's got to be between 0 and 2 pi. So it can't be negative 1.29 blah, blah, blah. So it's going to be positive. So your answer is C. All right, pretty easy question. Average value is not difficult. All right, so there's a few other questions for you to do. The next one is a bit tricky because you have to find the equation of the lines before you find the average value. Adds an extra element of difficulty. But yeah, you can have a go and the solutions are there for you. All right, see you guys.